boys and girls. Hello, and this is Miss Davis. Of course, you know that by now. But we are working on a new standard. And this video. I'm trying to get myself together. This video, we are working on standard Georgia Standard of Excellence 4 for 4th grade. OA stands for Order of Operations and Algebraic Thinking. And the 3 stands for the 3rd standard in this domain. And you're probably thinking, well, Ms. Davis, why didn't you record OA1 and OA2 yet? Well, Ms. Davis is going in order of the standards within the unit. So OA3 is the 5th standard for 4th grade in Unit 1. So you're probably like, well, you're missing OA1 and OA2. I know. So when you guys ask, where's NBT5? Oh, there is an NBT5 and an OA1 and an OA2. But they are in other units that you will get to. So I assure you, you're not going to miss those standards. We are just working on the standards within the unit. That is why when you look for my videos, you see Unit 1 videos. And those are all the standards that are in Unit 1. So just a little tip I wanted to point out to you guys. So OA3 has it's a pretty healthy standard, okay? And what I mean by that, it has a lot of good information in it that we have to break down to grasp the whole concept of the standard. So the first part of this video, or this video that I'm going to instruct with you guys, through you guys today, is part 1. Our lesson objective is to solve multi-step word problems with whole numbers using the 4 operations. Now, the strategy that we're going to focus on with this standard is cubes. The cube strategy is by far my favorite strategy to use for solving word problems. I don't care if you're in 2nd grade up to 12th grade. Cubes will be a strategy that I will always suggest for students to use because it gives you a step-by-step thinking process to use and that you can easily remember when you are working through a word problem. So I'm going to read the standard with you. Remember, have out your journal, your pencil, and please do not copy this down because it is already on your unit plan. So this standard says you're going to solve multi-step word problems with whole numbers and having whole number answers using the 4 operations, including problems in which remainders must be interpreted. Represent these problems using equations with a symbol or letter standing for the unknown quantity. Assess the reasonableness of answers using mental computation and estimation strategies, including rounding. So that is what we're focusing on today. So let's not waste any more time and get started. A quick review. I put up a separate video yesterday on just the cube strategy. Here it is for you right here. Circle, underline, box, evaluate, solve. This is the acronym for this strategy. We're going to circle our numbers, underline the question, box in keywords, evaluate your information, and solve. I can't write this in purple because that's already purple. Solve to find your answer. That's crazy looking. All right, so this is what cubes stand for. If you would like a detailed video on cubes, go back to your homepage for the videos on Unit 1 and it's there in all its glory, okay? Moving on. So we have our cube strategy out to the side. Ba-da-ba-ba-ba. Circle, underline, box, evaluate, solve. So what we're going to do, remember when I told you work with the cube strategy, you're going to read your problem one time by yourself. No pencil in your hand. Pencil free. And you know I'm going to use pens in math, so you shouldn't even have a pen nowhere in your hand. Pencil free. You read and you devote all your focus to this word problem. Get up on that word problem. Make that word problem your best friend, because you are going to solve it and you're going to feel good about yourself after you finish this word problem, okay? Using the cues strategy. So I'm going to read it. Nothing in my hand. Hands free. Let's go. Nathan's friends were collecting pieces of toffee to fill a box. Each friend had to find 11 pieces of toffee. At the end of the day, Nathan's friends had 242 toffees. How many of Nathan's friends participated? Okay, got it. Read through it. I know what's going on. While I was reading this, you know, Ms. Day is a little different. I was playing this out in my head. So I imagined some little boy named Nathan and his friends. I don't know how many. I see a whole bunch of guys and girls just collecting pieces of toffee to fill a box. Each friend had to find 11 pieces. Nathan was like, all right, you find 11, you find 11. Everybody finds 11 pieces. Go. All that is playing out of my head. So let's go ahead and begin with our cube strategy and circle our numbers in our word problem. So I'm going to circle 11, 242. Boom. Circle my numbers. Check, check. Now, we're going to underline our question. So I am going to go back through my word problem. What do they want me to find out? They want to know how many of Nathan's friends participated. Okay. All right. Now we're going to have to box in our keywords. So let's start boxing. Now to find the keywords, we have to really read through it again, because when you're just doing the first part of cube, circling your numbers and underlining the question, it's really easy to scan through it and be, okay, that's a number, that's a number. Even if the number is in word form instead of numerical form, like 11 and 242, you still will need to circle it because it's a number. It's just written in a different form. So be careful, be mindful, watch for that. And the question, in majority of the time, is always at the end of the word problem, so you can quickly underline that, read through it, make sure you have a question mark. That's the question. Now we can start boxing in our keywords. Our keywords are going to tell us if we need to add, subtract, multiply, or divide, or we have to do one or more of the other, okay? Nathan's friends were collecting pieces of toffee to fill a box. Go, Nathan. Each friend had to find each friend, okay? I'm going to box that in because when I think of each, multiplication automatically pops to my head. For me, each friend had to find 11 pieces of toffee. At the end of the day, Nathan's friends had 242 toffees. At the end of the day, okay? At the end of that's important. Because at the end of the day, that's how many pieces they had. But each person had to find 11 pieces. At the end of the day, that's how many they had. But each friend had to find 11 pieces. But we don't know how many friends participated in this toffee hunt. So let's figure that out. I boxed in my keywords. Check, check. Now I'm going to evaluate what I had. And I just did that out loud. I evaluated. Okay. Let's get down to the details. All right. Each friend had to find 11 pieces. At the end of the day, they had 242 pieces. All right. Well, 242 pieces, I consider that my answer because that was what they had at the end of the day. That was their total amount. But everyone had to find 11 pieces. So if someone brought me 242 pieces of toffee in my hand and said everyone had to find 11 pieces. Okay. So I need to figure out what's missing. What do I need to do? Maybe I could divide. Because if he's telling each one of his friends to find a certain amount, they're going to add up to 242. Or you get 11, you get 11, you get 11. When they get everybody's amount together, they multiply it by how many pieces they had to find, 11. That gave them 242. But we don't need to multiply because we already know how much they had at the end of the day. We just need to know how many people participated in finding the toffee pieces. So this is where it comes down to division. We are going to have to divide 242 pieces at the end of the day by 11, which is our divisor. In division, the outside number is your divisor. The inside number under the little roof of the house is your dividend. For some reason, I absolutely love that word, dividend. And then I have my sister who pronounces it like dividend. So when I heard her say it, being funny, I started saying dividend. And my students remember, under the house is the dividend. So the 11, I think of it as a door. The divisor wants to go through the door to dance with the dividend. It's my way of thinking. I know it's weird. You can laugh at me later. I don't mind. So we're going to divide 242, which is our dividend, into our divisor, okay? How many times can 11 go into 24? Well, I know 11 times 2 will give me 22. And 24 minus 22 is 2. All right, so I'll bring down this 2. Well, I already said that 11 times 2 is 22. So 11 times 2 again is 22. Ha! So 22 friends participated. Now let's check this. I evaluated my problem and I solved it. I say that it was 22 friends. How can we check this? If we divide it to find our answer, what's the opposite operation of division? Multiplication. So let's go ahead and divide 11 by 22. If we're right, we should get 242. So that's 2, 2, placeholder, 2, 2. Add those together. 2 plus 0 is 2. 2 plus 2 is 4. 0 plus 2 is 2. Bada boom, bada bing, bada bam. It checked out. Check, check. 22 is our answer. I know I spent a lot of time on this word problem, but I was trying to be as detailed as possible. But you're going to get some practice. We're going to do what I do, we do, and then you do. Yes, you do. So let's move on. Take the time and copy down this word problem. Pause the video. Copy this down. Do not draw the pictures. There's no need. Don't draw the pictures. Just copy this down. All right. Janelle purchased, pin down. Janelle purchased 15 ice cream cones and 5 cups of pudding. The girl was hungry. Each ice cream cone costs $5, and each cup of pudding costs $2. How much more did Janelle spend on ice cream than on pudding? I already got something playing in my head. First of all, in my mind, Janelle purchased 15 ice cream cones filled with cookie dough. I'm just saying. I love cookie dough. Wait a minute, I'm not going to be. And Oreo. A. That's my preference. I love cookie dough and Oreo. And the 5 cups of cheesecake pudding. No? Everybody agrees? Okay, great. So, each ice cream cone costs $5. Let's go ahead and write out to the side our wonderful, wonderful cubes. This is such a great guide. I absolutely love it. All right. Janelle, we're going to circle our numbers. So, 15, 5, $5, and $2. So I just circle all my numbers. Now let's underline this question. How much more did Janelle spend on ice cream than on pudding? Okay. Now, we did that. Underline our question. Let's box in our keywords. Keywords. Janelle purchased. I would like to think purchased is a keyword because if you're buying something, the person you're buying it from is getting money, so you're adding more money to their pile. But if you're purchasing something, you're subtracting money from your pockets, basically. We're going to hold off on boxing in purchase for right now and continue reading on until we find a really good keyword that jumps out. Janelle purchased 15 ice cream cones and 5 cups of pudding. Whoa. And I'm going to go back to purchase because she bought 15 and then 5 of something. Each. Ooh, each. I love that word. We had the word each in our other word problem. Now, when I see the word each, I think multiplication. I'm just saying. And when I see the word and, I think addition. I'm just saying. Each ice cream cone costs $5. And, oh, there's that and again. And then each, what? Each cup of pudding costs $2. How much more did Janelle spend on ice cream than on pudding? If you're spending money, you are losing money. So you're subtracting money from yourself. So I just boxed in my keywords, okay? Now I'm going to evaluate what I'm working with. All right. I'm going to put ice cream over here. And then I'm going to put pudding, cheesecake pudding, because it's so delicious. I'm just not going to lie. It's so good. I'm sorry. Alright. Janelle purchased 15 ice cream cones. Bada boom, bada bing, da bam. And 5 cups of pudding. 5 cups of pudding. Each ice cream cone costs $5. So I could do 5 plus 5 plus 5 plus 5 plus 5. Write out 5 15 times. But who has time to do that? Not Llewellyn. No, we're not going to do that. Not us. Because we know that repeated addition is the foundation for multiplication. So 15 times 5. 5 times 5 is 25. 5 times 1 is 5, plus 2 is 7. So $75. Awesome ice cream! You have got to be kidding me. Somebody must have done something really amazing to make Janelle buy 15 ice cream cones. I'm sorry. And 5 cups of pudding. Okay. And each cup of pudding costs $2. Alright, so 5 times 2. You guys should know that. 10. So that's $75, and then that's $10. How much more did Janelle spend on ice cream than on pudding? Well, she spent $75 on ice cream and $10 on pudding. So how much more did Janelle spend on ice cream than on pudding? My keyword spend, I put subtraction sign underneath it because I was thinking to myself, well, if Janelle spent, spending is subtracting from yourself. That's what put me in the mind frame of wanting to do subtraction. I could subtract as a strategy. She had $75 that she spent in ice cream, but she only spent $10 on pudding. They want to know how much more money did she spend in ice cream than in pudding. So 5 minus 0 is 5. 7 minus 1 is 6. She spent $65 more on ice cream than on pudding. I can check it by adding 65 plus 10. That should give me 75, which it does. So my answer is $65. That's how much more she spent on ice cream than she spent on pudding. I guess she doesn't like cheesecake pudding. I don't know. Her choice. Now it's time for We Do. Pause the video. Copy this down in your journal. Once you press play again, I'm going to start working it out. Jenny wants to buy a history book that costs drop pen. Jenny wants to buy a history book that costs $8, an art book that costs $4, and a children's book that costs $10. She must have been in Barnes & Noble or Books A Million. I don't know, but she was having a good time looking at those books. She has saved $18 from her pocket money. How much more money does Jenny need to buy all 3 books? All right, let's go ahead and run our cubes out to the side. Cubes, 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 cubes. What am I doing? Stevens has butterfingers. It's all over the place. Boop. All right. Now, we're going to circle our numbers. $8, $4, $10, and $18. And all 3 books. Look, I have numerical for $4, $8, $10, $18. But look, they have the word form of the number 3. I'm still circling it because it is a number. We don't know how important that number is. We can end up ruling that out after we get to the point of evaluating information that we have in our word problem. So, circle, check, check. Moving on. Underline the question. The question was, they want to know. They want us to find out. I'm sorry. How much more money does Jenny need to buy all 3 books? All right. Did that, check, check. Now we're going to box in those keywords. Jenny wants to buy. Buy, buy, buy. That's the key word. If she's buying something, she's going to be giving her money to somebody else. So that amount is being subtracted out of her pockets. So, buy a history book that costs $8. An art book that costs $4. And, look here. And, I put an addition sign above the word and because when somebody's listing something and they have the word and within that list of different things in that word problem, that means you're going to be adding something together within that list, okay? And a children's drawing book that costs $10. She has saved $18 from her pocket money. How much more? Much more. How much more money does Jenny need to buy all 3 books? A word all, that's important. I say all 3 is important. Even though we circle the word form of the number 3, I am still going to box that in. And it's also underlined as well because it's part of the question. It's letting me know that I'm going to add the total of all of it together. When someone says, give me all of that, give me all of it. You give it all. I cannot keep this pen in my hand. I am so sorry. Keep all of it. All. So I think all I'm going to be adding to what I don't have. Give it all to me. Give me all of those pencils. Someone puts a slew of pencils in my hand. They've added to what I did not have. All of it. All right. Now let's go ahead and evaluate what we're working with. This is what I'm going to do. Me personally. All right. The history book costs $8. The art book costs $4. And the drawing book costs $10. She saved $18. How much more money does Jenny need to buy all 3 books? This is book number 1, book number 2, book number 3. Pause the video and figure out this portion. What do you think you need to do? If she wants to buy all 3 of these books, what do you need to know? How much all 3 of these books cost? I just told you what you need to know. Pause the video, figure out this amount, and then press play. $8 plus 4 plus 10 is $22. But she only saved $18. So she's short. But how much money is Jenny short? I said Janelle. How much money is Jenny short? $4. How much more money does Jenny need to buy all 3 books? Well, all 3 books cost $22. She only has $18. You guys can also use a number line. Her goal is to buy $22 worth of books. $21, $20, $19, $18. This is how much she saved. $18. She wants to buy $22 worth of books. So how much money does she need? $1, $2, $3, boom, $4. She needs $4 more so she'll be able to buy those books. So Jenny's gonna have to put away something, probably this art book. She'll have to come back and get it out another day. All right. Now you do. Pause the video, copy this down, work it out completely. Don't forget to write your cubes strategy to the side and check off as you do each part. Remember, put the pencil down, read it one time. After you've read it one time, pick your pencil back up and start going through each checkpoint in your strategy known as cubes. All right. Shelly bought 7 boxes of fish food and 2 packets of cat food. Each box of fish food contained 6 pouches. And each packet of cat food contained 4 pouches. How many more pouches of fish food than cat food did Shelly buy? In my head, I was imagining Shelly in line at the checkout counter at PetSmart buying these things. She has fishes and she has cats. All right, come on, Shelly. Circle our numbers. So we have 7. We have 2. We have 6. And we have 4. So, numbers, circle numbers, check. Underline the question. How many more pouches of fish food than cat food did Shelly buy? Pouches. Okay, that's a key word. Why did I do that in blue? On blue. Doesn't make any sense. All right, box. She bought. She's buying stuff. It could be addition or subtraction, so we'll just put both of them there. Both. Shelly bought 7 boxes of fish food and so she's 2 packets of cat food. I say you can still put addition and subtraction because you're subtracting from your pockets, but you're adding to PetSmart pockets. Each. Oh, that word each. I think multiplication every time. Each box of fish food contains 6 pouches, and each, and addition, each, I'll put multiplication, of cat food contained 4 pouches. How many more pouches of fish food than cat food? Okay. So I'm going to go ahead and talk about the fishes. Bloop, 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 bloop. My fish looks kind of angry. All right, fish food. And then cat food. You don't have to draw this. Please do not talk about my cat. All right, fish food, cat food. You don't have to draw it. I'm just bringing a little life to the video. I just wanted to draw. Sorry. All right, shut about 7 boxes of fish food. 7 boxes. 2 packets of cat food. Each box of fish food contains 6 pouches. So 7 times 6 is 42 pouches. And each packet of cat food contains 4 pouches. So 2 times 4 is 8. How many more pouches of fish food than cat food did Shelly buy? So over here she has 7 boxes. Each box had 6 pouches. So here's a box of 7, so that's 6, 12, 18, 24, 30, 7. Where am I going by?